Sixth grade math teachers, welcome back to another Prep Talk video. In this video, we will cover the coordinate plane and linear relationships, TEKS 6.4a and 6.6a. In this unit, we've already covered graphing points in all four quadrants. Now we will move into identifying independent and dependent quantities from tables and graphs and comparing additive and multiplicative relationships. These are things that students have some prior knowledge on based on what they've learned before sixth grade, and we will try to utilize that when we teach the new concepts in sixth grade. Here is a quick look at the TEKS that we will be discussing in this video. 6.4a and 6.6a are supporting standards. They show up every so often on the STAAR test, not every year, but certainly more than 0 times. And so these are supporting standards that we do want to pay some attention to, especially because for 6.4a, as I mentioned, they have some prior knowledge from 5th grade, and 6.6a is a low-hanging fruit question. If we can get students to understand the difference between an independent and a dependent quantity, 6.6a should be a question that they get relatively easily. And so we want to focus our time on these two TEKS. Let's take a look at the way this has been tested in the last 5 years. On last year's test, we were given 2 data sets and asked to determine the statement that best describes the relationship between X and Y in each of the data sets. As you take a look at the first data set in this 2022 released question, what you'll notice is that Y is always 4 times more than X. You can also see that the Y values are increasing by 4 every time. This indicates a multiplicative relationship where, again, Y is 4 times more than X. You can see that if we go this way in the table, this is times 4. Anytime you have an X value and you multiply it by 4, you end up with the corresponding Y value in data set number 1. We call that a multiplicative relationship because we are multiplying the X value by some constant in order to arrive at the Y value. What we notice in data set 2 is that each time we go to the next Y value, we are increasing by 1 every time. That is a very strong indication that this is an additive relationship. What you can also notice is that if you go from X to Y, to get from each X coordinate to its corresponding Y coordinate, you will add 4. And so this is what we call an additive relationship, where we are taking the X coordinate and adding 4 so that we can get the Y coordinate. Or another way to say that is that Y is 4 more than X. And that's the language that you'll want to use with your students, because as you look at the correct answer choice in letter C, it tells us that data set 2 shows an additive relationship in which Y is 4 more than X. And so we see that letter C is the correct answer for 2022. In 2019, what we're going to see are vertical tables, and so as opposed to in 2022 when we saw a horizontal table. So you'll want to make sure that students are seeing both types of tables. What we notice in data set 1 here for this question is that we are adding 5.5 each time to get to the next Y value. And so because we are not just adding 1, but we're adding 5.5 each time, this is going to be a multiplicative relationship where Y is 5.5 times more than X. And you can verify that by going from X to Y and noticing that each time you will be multiplying by 5.5. Then in data set 2, what we notice is that we are going up 5 as we go from Y value to Y value. And so again, because we're not just going up 1, but we're going up 5, that would indicate that this is a multiplicative relationship again. And this one's perhaps a little easier to determine because what we can see here is that we're not multiplying by 5.5 times X to get Y, but we're just simply multiplying by 5. 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. and etc. And so if we look for the correct answer, since both of these are multiplicative relationships, our correct answer that we're looking for in this case is going to be letter C. Before I move on from these two problems, one thing I want to note is that it's very likely that this could be an inline choice problem in the future. And so if you think about it, if we just created a sentence stem here where students have to perhaps fill in that word, fill in this part of the phrase, fill in this part of the phrase, we could easily make this into an inline choice. I mentioned earlier in the video that students come in with some prior knowledge in the area of 6.4a. TEK 5.4c from 5th grade says that students should be able to generate a numerical pattern when given a rule in the form y equals ax or y equals x plus a, and then be able to graph. And so what students would do in this particular case is take the rule that they were given, y equals x plus 3, and begin to generate a numerical pattern. So for example, they might start with 1 as an x, and they see from the rule that in order to get y, they do x plus 3. And so if they add 3, they're going to get 4 as their corresponding y coordinate. Then if they went to the next x coordinate of 2, adding 3 to that based on the given rule would give them the corresponding y coordinate of 5, and then going to the next x coordinate would be 3. Adding 3 to that based on the given rule would give the corresponding y value of 6. And then students would look for the graph that has those ordered pairs on it. And so in this case, that would be letter B. And so what students are seeing is that this set of y values is increasing by 1 every time, and that y is 3 more than x, which is just the verbal way of saying this equation. In the problem on the right, it's sort of going backwards. They're this time given the rule and the graph and asked to determine the table that would go along with it. And so if they're able to understand the rule, y equals x plus 5, meaning that if we want y, we're going to make the x 5 more, then what they would notice is that letter B is the correct answer. And again, noticing that if I add 1 to the y values, that is going to get me to the next y value in each case. And there's actually a supporting TEK that also goes along with this concept that we teach in 6th grade. TEK 5.4d says that students must be able to recognize the difference between additive and multiplicative numerical patterns given in a table or a graph. What changes in 6th grade is that they also have to be able to do that from an equation, and usually they have to do 2 rules. That's why our TEK says 2 rules: verbally, numerically, graphically, and symbolically. But you can see that students have already been doing this from a table or a graph in the 5th grade. And so what they would notice in the 5th grade is that if I have the number of students joining here, then the total number of students at the table is always 5 more than that. And so this x value, if you want to call it that, can be added to 5 in order to get the corresponding y value, or the total number of students at the table. And so because it is 5 more than, that means that it is an additive relationship. And so therefore we would be looking either at A or C. And A is the correct justification because the pattern is to add 5 to the number of students in order to get the total number of students at the table. In the question on the right, they're given a table and just have to determine from that whether it is multiplicative or additive. Now, what you'll notice here is that the x coordinates are not evenly spaced. And so my trick of seeing if it just goes up 1 each time is not going to work. So you're going to want to be careful explaining it that way, because sometimes the table has x values that are more spread out than just 1, 2, 3, 4, 5. And so we really need to determine, is this additive, meaning that we're adding something to x in order to get y, or is it multiplicative, meaning that we're multiplying x by something in order to get y. And a quick investigation here shows us that in order to get the y value, each time we're going to be adding 6 to the given X value. And so that makes this relationship additive. And the reason it is additive is, of course, because the Y values are 6 more than the corresponding X values. And so while it can sometimes be a shortcut to see if the Y values are going up by 1, it only works whenever the X values are going up by 1 as well. And so be very careful to not explain it in that way. It just is sometimes a good check. But really the best way to do it is just to look. Am I adding something to the X values to get the Y values? And is it the same number every time? Or am I multiplying the X values by a number in order to get Y? And is it the same number that I'm multiplying by every time? So with all of that being said about the prior knowledge that students come in with on this skill, one way that you might introduce this is through a little pre-assessment. And what you can do is just put this stimuli up on the board, this table, and ask the simple question: what do you notice about the image? Now, some students are going to sit there and not really be able to say anything maybe, but you can pull something out of them. It's a table. That is something to notice about the image. Some students may go back to 5th grade and remember the difference between an additive and a multiplicative relationship. Give about 2 or 3 minutes for students to write everything that they notice about the image as you walk around and investigate what they are writing down. Then in phase 2, you may ask them to add any of the following vocabulary words to their response. And through doing this activity, you're going to pull out some of that prior knowledge that they have from 5th grade and be able to see where your students are and meet them in that need as you begin to teach your lesson. As we move into the next concept that I want to cover in this video, let's look at this released question. Students need to identify independent and dependent quantities from tables and graphs. Students can use their prior knowledge from science class where they have discussed the idea of an independent variable, which is the variable that you control in an experiment. It's called independent because it's not influenced by any other variables in the study, or it does not depend on anything else in the particular context. And so as we look at this question, the table shows the total number of calories a person used while exercising. Well, as we look at the 2 variables involved in this particular context, we have time in hours and the number of calories used. We can ask ourselves the question: does the amount of time I spend exercising depend on the number of calories that I use up while exercising? Well, no, it certainly doesn't. I am the one who controls the amount of time that I work out. And so that means that time in this particular scenario is the independent quantity. Does the number of calories that I use when working out depend on the amount of time that I work out? Yes, it absolutely does. And so therefore, this is the dependent quantity. What are the values that represent that dependent quantity? Well, that would just be 0, 267, 534, etc. All of the available numbers in this particular table that are associated with number of calories used. You'll notice from the very beginning that it's not enough just to say that X is always independent and Y is always dependent, because this problem does not ever present an X or a Y in that mathematical context. This is in a real-world scenario, and students really need to be able to decipher what is depending on what in order to find that dependent or independent quantity. So again, another example here, you can reason through it exactly the same way. Does the number of weeks depend on the total amount that I save? Well, no, it doesn't. Number of weeks is what I control in this context, and so that's going to make it the independent variable. Do the number of dollars that I save depend on the number of weeks that I save money? Yes, it absolutely does, and so therefore, total saved in dollars is going to be the dependent quantity in this scenario. So what are my dependent quantities? 25, 50, 75, etc. We need to make sure that we get the entire list. You'll see some of the ways that they like to distract in this case. Notice that letter C is the independent quantities in this particular scenario. And then to be perfectly honest with you, I'm not really sure where A comes from, but it is not correct. I guess that is probably adding the X and the Y coordinates, the independent and the dependent quantities. I'm not really sure why a student would do that, but that is the other distractor that they came up with other than none of these. So make sure that your students are able to immerse themselves into the real world scenario and ask the question, what depends on what in this real world context? You'll notice that the last question that we have released is a graph, and so students need to be able to do this from a graph as well. And so reading this graph, what we notice is that we have two different axes. We have one that represents the amount of time in hours and another that represents the cost in dollars to rent a surfboard. And so we ask ourselves the question, does the amount that it costs to rent a surfboard depend on the amount of time that I rent it? Yes, it absolutely does. And so therefore, this is the dependent quantity on the y-axis, and this is the independent quantity on the x-axis. And so in this case, we're being asked for the independent values. So we might want to make sure we're using that word in our instruction as well, not just quantities, but values also. And so what we notice is that the independent values are 1, 2, 3, 4, 5, and 6. And so that would lead us to answer J as the correct answer. If you have any questions about additive and multiplicative relationships or about independent or dependent quantities, please feel free to reach out to either myself, Ryan Castle, or our middle school math facilitator, Paris Scott, and we would love to answer whatever questions you have on these two TEKS. As always, before you go, please make sure that you fill out our survey with the QR code to the left or the link provided on the screen. This will give you the opportunity to ask questions if you have them, or just give us some feedback about if you're enjoying the videos. Thank you so much for watching, and good luck as you continue your journey through 6th grade math.